my still viewers all over the world. I remain Salumaj. Today, I would like to teach us on how to derive sine 45, sine 30, sine 60 without using four-figure table. I mean, the Sokatua, you are going to derive them as in sine, cos, tan without using your four-figure table. And after this, I will take time to teach us what is called sort. Very interesting. I had A1 in mathematics. Very simple. Very simple. Mathematics is as simple as A, B, C. Just follow me the way I will make it so explicit. If I could get A1, then you can still get A1. Anybody can get A1 in any subject. Once you follow the principle, like I always tell you guys in all my videos, that principle is universal. The principle I will apply here to solve the mathematics, if somebody applies it in any part of Europe, they will get the same answer. Principle is universal. Today, I would like to teach us on how to derive angles 30 degrees, 60 degrees, 45 degrees without using four-figure table. You don't need four-figure table. And let's go. To determine this, we need two triangles. Two triangles. The first triangle is this. Look at the sign. If I put these signs, what does it mean? It means this side is equal to this side, and this side is equal to this side. But once I do this, it means the sides are not equal. It means only these two sides are equal. But if I do this, it means these two sides are equal and not equal to this. But if I do this and I do this, like this, it means the three sides are not equal and they all bear different names. Like this one now, this is a scaling triangle, really irrespective of the size. So this is a scaling triangle, they have different sides. But if I change this to this, you can see these two sides are equal. I've changed from scaling to isosceles triangle. Isosceles triangle means that what? Two sides are equal. Then if I now clean this, like this, what do I call this? The signs are what? The same. So this is what? An equilateral triangle. So we use equilateral triangle to derive angle 30 degrees and angle 60 degrees. Just follow me. It's very simple. For us to derive this, we do like this. Let me central this. Let's say, follow me. Very simple. Let's assume that this place is 1. You know, equilateral triangle, we say all sides are equal. And I've drawn an imaginary line here to divide this into 2. This is a line of bisection, not dissection. This is a line of what? Bisection. Bisection means it has divided into 2 equal parts. If I say dissect, it may not be equal. But this is a line of what? Bisection. Let us assume that this is 1. If I call this place to be 1, this place automatically is going to be what? 1. Because it's a line of what? Bisection. So if I now say, oh, if this place can be 1, and this one is 1, then what is now from here to here? Meaning that from here down to this place will be what? 1 plus 1, which is what? 2. Let me rub off this equilateral I wrote here. But just know that it is equilateral triangle. equilateral triangle. Meaning it has 3 sides. So this is now what? 2. 1 plus 1 will give us 2. Meaning from this side to this side, if I want to label it, I can say this A, B, C. So from line A to C, it is what? 2. If A to C is equal to 2, what will now be A to B and B to C? If A to C is equal to 2, I will say it is what? Equilateral triangle, meaning all the sides are equal. Once all the sides are equal, then the angles, the interior angles will also equal. So we have this to be 2. Definitely this one will be also what? 2. this one will also be what? 2. Meaning that line AC is equal to line AC is equal to line AC is equal to line AB is equal to line BC. If you don't want to write it this way, you can say AC is equal to AB. You are still saying the same thing. Don't allow anybody to bamboozle you. You are still saying the same thing. Line AC is equal to AB equal to BC. If line AC is 2, therefore AB will also what? 2. And BC will also be what? 2. It's as simple as ABC. So let's continue. Now I want to bring out some here. Now here we have equilateral triangle. But from this equilateral triangle, we have brought out another triangle. If you look at it, I've drawn a line of bisection. Because this one has bisected this, it has made this angle to what? 90 degrees. So I now have two right angle triangles. Let me now bring out one. Maybe I brought out this one. I brought out this one. This is now the angle 90 degrees. So this place is what? 2. This place is what? From here to here is 1. You can decide that, okay, I don't want to work with this triangle. I want to work with this triangle. You can bring out your own this way. It's still the same thing. So what will be this one? From here to here is what? 1. What is from here to here? 2. So you don't know this third part. We don't know this third part. We can call this third part to be what? X. This X, no, this line is still the same thing as this. You can call this one X. It's still the same line of bisection that you want to determine. And don't forget, what do we have here? We have 2 known and 1 unknown. The same way, you have 2 knowns, then 1 unknown. I told you, for you to use Pythagoras theorem, you must know 2 sides, then you can now determine the third side. So from our Pythagoras theorem, label first. And if you look at this, let's go back to this. This is an equilateral triangle. In the equilateral triangle, all the angles are equal. If the angle, all the angles are equal, if I call this one to be X, I call this one to be X, I call this one to be X. It means X plus X. Sorry, let me clear this place so that you can see what I'm doing. It means X plus X plus X is equal to 180 degrees. Then we have 3X, or I can use another alphabet because like that one I want to determine so that you don't get confused. I can call it Y because I'm already using X in my question. And I told you in mathematics, when they use alphabet, it means unknown. I'm already using X. That's why I just changed it so that you don't get confused. So we have 3Y, Y plus Y is equal to 3Y. It's equal to 180 degrees. Then we have Y equals to 180 divided by 3. Y is equal to 60 degrees. It means the angle here is what? 60 degrees. If this is 60 degrees, this one must be what? 60 degrees. Now look at it. Instead of this one to be 60 degrees, there is a line of what? Bisection. Bisection means it has divided this angle into what? 2. So this is now 30, 30. So if I come here, this will be what? 60 degrees. And this will be what? 30 degrees. The same way, this will be 30 degrees. And this will be what? 60 degrees. Can you see the way I'm filling up the whole stuff? So now look at it. Let's assume that I want to determine this X now. Then from Pythagoras theorem, we know that this place, where the angle box, where this box is facing, is called what? The hypotenuse. And meanwhile, if we want to derive the formula, we can just close our eyes on this. You close your eyes on this. You allow this one to be the opposite. I hope that is clear. Close your eyes on this. Allow this one to be the opposite. Since you want to determine for angle 30 degrees first, this is where we are going to close. You can close this. Or you can consider anyone for us to determine this X for now. So if I say, okay, let this one be, let this one just be, let me allow this one to be the, what do you call it? Let this one allow this one to be the opposite angle 60 degrees. So because I can't have two opposites, that's why I have to rub off this so that this one can stay. So if I allow this one to be the opposite, this is now the opposite, and this is what? The adjacent. If I say, okay, no, I want 30 degrees, then you can rub up this again, rub up this, rub up this, you can say 30 degrees, then this one will now be what? Opposite, and this one will be what? Adjacent, because we already have our hypotenuse, whichever way. So if we now go with this one, since it's smaller angle, we now say that from Pythagoras theorem, we know that hypotenuse squared is equal to opposite squared plus adjacent squared. So what is our hypotenuse? Our hypotenuse is what? 2. 2 squared is equal to, what is the opposite? Our opposite is what? 1. What is adjacent? Is what? X. That is what we want to determine. 1 squared plus x squared. So we now have, simplify this, we have 4 squared. So no, 2 raised to the power 2 is 4. Is equal to 1. 1 squared is 1 times 1, which is 1, plus x squared. So we now have 4 minus 1 is equal to x squared. So we have x to be equal to what? Square root of 3. So it means this place is what? Square root of 3. This one is what? Square root of 3. So anywhere you find x, square root of 3. So now, since we have solved for this, we can now go back to go and solve for how to determine sine 30. Because we are using angle 30 degrees. So let's say how to determine sine 30 now. Just follow it. It's as simple as A, B, C. Just follow me. Trust me. So we now have sine 30. The sides are now complete. So we have all the sides are now complete. We have, this is 30 degrees. We want to determine. So this place is 2. Why this is 1? And this was square root of 3. So for me to determine sine 30, what is sine? Sine theta is equal to what? Opposite all over hypotenuse, from SOHCAHTOA. Opposite all over hypotenuse. Opposite all over hypotenuse. Ka. That is cos theta. Cos theta is, that's the short form of cosine. Cos theta is equal to what? Adjacent all over hypotenuse. Adjacent all over hypotenuse. Then we have tan theta. Tan of that angle, tan theta is equal to opposite all over adjacent. So we now have this, what is our opposite? Our opposite from here, don't forget this is our angle 90 degrees. So we now have sorry for that. Opposite is 1.